All right, so let's talk a little bit about pigments and dyes. So a pigment is a material that actually changes the appearance of light by removing or absorbing one or more colors. A dye is a molecule that does the same job. A dye is a molecule that sticks to materials like clothing fibers and reflects some colors of light but absorbs other colors. And by taking away certain colors, certain parts of the spectrum, I then change what my eyes will see. So how does this work? All right, a pigment or dye that removes one primary color is called a primary pigment. It's called a primary pigment because it removes exactly one of the three primary colors. But remember, if I remove one primary color, there is two left. And we saw that mixing two primary colors is going to give me a secondary color. So what's confusing here is that primary pigments always look to our eyes as a secondary color. So our primary pigments are cyan, yellow, and magenta. So here's a practice question. What happens when white light strikes a spot of yellow pigment? All right, let's take a look. Well, I start with a ray of white light, which is really a mixture of all the colors of the visible spectrum, Roy G. Biv. But our eyes cannot perceive all the parts of the spectrum. Our eyes are really only sensitive to the red part, the green part, and the blue part. So instead of working with all these colors, I'm only going to work with red, blue, and green. And so I can take white light and substitute in red, green, and blue rays because that's what our eyes see. Now it's going to strike a spot of yellow pigment. Perhaps this is paint or a dot from an inkjet printer at home. Well, the yellow pigment looks yellow to us because it absorbs the blue light. It takes the blue out of the light shining on it and reflects the red and the green light, which is why it looks yellow. So yellow light will remove the blue. What will bounce off the yellow light is the red and the green, which our eyes perceive as yellow, and that's why yellow paint looks yellow to us. Our eyes see only the light that's not absorbed. So a primary pigment always appears to be a secondary color because it's leaving two primary colors of light behind. All right, let's look a little bit at printing. Well, if I wanted to print a color picture, printed images appear to be painted in continuous colors, but in reality, they're made by grouping thousands of dots very close together of these pigments. So remember, the primary pigments are yellow, magenta, and cyan. So most printing actually only works with those three colors, and black dots as well to completely absorb the light. So to our human eye, a primary color is perceived by the light reflected by two dots of the primary. That is, so what's happening is this. So if I take a look at this magazine photo, if I looked at it under a microscope, I see that it's actually made of lots and lots of tiny dots. Now, you may be able to see this on your computer monitor, I'm not sure. On the website, I have a video of a better demonstration of this using a computer microscope in an actual magazine picture. But let's take a look at what happens when I take two pigment dots and put them close together. So what color is seen when white light shines on a combination of yellow and cyan pigments? So I have a bit of yellow paint mixed with a bit of cyan paint, or a yellow and cyan dot right next to each other. Well, white light again is perceived as red, green, and blue. So from now on, whenever I see white light, I'm going to substitute a red, green, and blue ray for the white light. First, let's look at the yellow pigment. As we saw before, the yellow pigment removes the blue, leaving behind red and green, which is why it's perceived as yellow. Well, that red and green light then is going to interact with the cyan pigment. The cyan pigment looks cyan because it's a mixture of blue and green. So it removes the red. So the yellow pigment removes the blue, the cyan pigment removes the red. The only thing left is is green. So if I put a yellow and cyan pigment very close together, I will see mostly green light reflected off the page, and so I will perceive green. And that's how we generate green. Again, any other color is made by mixing different amounts of yellow, cyan, or magenta pigment until we get the right ratio of color bouncing off the page that our eyes will perceive whatever color we're trying to print. Okay, let's do some practice. All right, so some practice problems. So I have white light is reflected by magenta and yellow pigments. What color is the reflected light? Okay, so let me turn the pen back on. I'm starting with white light, which again I will now represent as red, blue, and green. It's first going through a magenta pigment. So pigments work a lot like the filters did. So here is a magenta pigment. This line represents magenta pigment. It's magenta because it's going to reflect red and blue. That means the green arrow is going to get absorbed. So I bring the red arrow through, and I bring the blue ray through, and next I strike a yellow pigment. Now, yellow pigment looks yellow because it reflects red and green. Well, the blue's not red or green, so the blue gets X'd out, and the only thing that comes through is red. So I would see red. All right, question 4. Cyan light is reflected by yellow pigment. What color do you see? So I'm not using white light now. I'm using cyan light, which means to my eyes that's a mixture of blue and green. So I will start with a blue ray and a green ray, because that is cyan light, just as this represented white light. So I'm using yellow pigment. Well, again, a yellow pigment will reflect red and green, which is why it looks yellow. So it's going to X out the blue. The green light will bounce off the yellow pigment, and I will see green. What color is a red apple under yellow light and under cyan light? Well, we might at first say, well, a red apple is going to look red. But remember what seeing actually is. To see a red apple, red light needs to bounce off the apple into our eyes so we can perceive the red light. So if there is no red light available, the apple will not appear red. So yellow light is made up of red and green light to our eyes. But it's striking a red apple. Well, the red apple looks red because it's trying to take away all the light other than red. An apple doesn't glow. That would be a bad apple. An apple can only reflect the light that's around it. So red light, a red apple is going to absorb green and blue. So the green light's going to go away, and under yellow light, my red apple will still appear red. Well, what happens if I use cyan light? If I use cyan light, that's made up of the colors of blue and green. Again, I'm striking my red apple. My red apple looks red because it reflects red light. That means it does not reflect blue, and it does not reflect green. So what would a red apple look like under cyan light? Well, there's no red light to reflect. If nothing reflects off the apple is going to look black. All right, I hope these examples help you with the assignment. If you have any questions, you know how to contact me through the website, and I will see you next week.